In this video, we're going to continue with our infrastructure as code. In the last video, we built some playbooks and pushed some initial configuration. We're going to advance that, take that further, and we're going to configure all of our device interfaces and then IP addressing on those links that need it. So if we look at our diagram and where we were, we have just a small bit of logging in NTP configuration, but now we want to configure the IPs on these links. So this link between 1 and 2 is a routed link. 2 and 3 is a routed link. Here we have a sub interface. So this will be an interface with a dot and then a VLAN. This will be VLAN 10 going down, and then this will be VLAN 20. And then we'll configure this link up to the ISP as far as IP addressing. So by the end of the video, we won't have full reachability with everything, but everything will have IP addressing. So and the interfaces will be configured. So PC1 should be able to reach its gateway. PC2 should be able to reach its gateway. And that's what we're going to work on and build in this video. So if we get to the lab, what we're going to do is we're going to describe for each network device basically what we want the interfaces to look like. So we're going to make a file, put all the interfaces in there. That way you can look at the file and you can kind of get an understanding of, okay, I'm defining how I want this device to look. And then we'll use an Ansible module and within a playbook to make that happen, to push that and make that happen. So let me make a few files and then I'll explain how this works. So the first thing I'm going to make is a hostvars folder. Don't confuse this with the group vars that we had earlier. So let me make this directory and show you the only new thing that I just made was this hostvars. Remember, this contains variables for groups. This is going to contain variables for each network device that we have. So we're going to want to represent each network device under this because this is where we define things that are different between the devices. All right, so all I did was create an empty file. That's what the touch command does. And then now let's look at our structure here. So I just have a file representing each network device. Let's start with router 1 and let's populate the interface section of it. All right, so what we have here is it's an interface, it's a key, and then we can see it's a list of the interfaces. I'm giving it the name. The state is going to be shut, no shut. And then here's the second item, which is the name, state. In this case, it's a VLAN. It has an IP address. And then this also, you can kind of see what's going on if you think about it. This one's a sub interface. I know that because, most of the time interfaces don't have a VLAN. So if you think about how to create a sub interface on the router, you type interface gig 1.10 and then you specify a VLAN. That's what that's going to be used for. This one, there's no sub interface here. It's just going straight. So in our case, let's look at this diagram. Here's router 1. Gig 1 is going to be facing down. Gig 2 is going to be facing towards router 2. So as far as how to structure this, it helps if you know the module you're going to use, which is it's this Cisco IOS, which we've seen, and then there's a layer 3 interfaces. And it takes, like when we go to make the playbook, we'll have to type the config IPv4 address, and we'll come back to this, but it'll be a little clear about how I'm structuring this to make it match this a little bit. You could make this kind of however you want, but you have to just build the logic in the playbook. So this all makes sense more later. Let's go to router 2 now. So here's router 2. It's pretty simple. Again, we're defining the interfaces we want, and I'm putting the IP, and then I'm putting a /24. Again, the module that we use is going to know how to interpret that into 255, 255, 255.0. So again, they're both going to be enabled. We want to make sure they're not shut down. So let's go to router 3. And router 3 looks a lot like router 1, so we have a physical interface with no IP. just to make sure it's not shut down. And then our sub interface here, which is going to be on VLAN 20, it does have an IP. And then this interface goes upstream. So similar. Now let's look at a switch. It'll look a little different here. So here's our switch. Let me pull up this diagram. So we have interface 108, which that's going to be going up here towards the router. It's going to be enabled. It's going to be in trunk mode. And then the allowed VLANs we want over is 10, 11, 12, 13, 14, 15. We're not going to use all those. I just wanted to, make it a little more interesting, because you may, if you have a sub interface, you'll probably use more than one VLAN. So this is how Ansible is going to turn this into, the switch port trunk allow VLAN 10, 11, 12, 13, 14, 15. It will take care of that for us. And then here's the interface down towards the PC, gig 101. It's a mode access, and then it's on VLAN 10. And of course, it's no shut. Both of these are no shut. So this switch 2 will look really similar. Let's look at that one. So here's switch 2. It is just the opposite, except for there's, VLANs 20 through 25. That's going to be allowed on the switches 108, which is going upstream, and then downstream 101 towards the PC2. It's VLAN 20 access, and it's enabled. So let's save this, and let's look at some verification commands, because sometimes it's helpful to sometimes you want to know what the network device looks like, so you know how to write your playbook. So one new command, there is Ansible inventory, and then if you do -list, what this does, it shows you all your devices, and it shows, notice what it's pulling from, all the variables that it's inheriting. So it's getting, all these files we defined. There's the interfaces we just defined. So it's kind of a collection of everything. This is what Ansible knows about your device. And there's a lot, there's a lot of output here. If we wanted to narrow on one device, let's look at switch 1. It is a limit, and then switch 1, or whatever device you want to look at. So now I can just see this is how the interfaces are structured. So here, when we build our playbook, when Ansible configures it, it has, as switch 1, access to all of these values. So this is just a good way to come back and see, how does the inventory look, because you might need to know that. All right, now that we have all of our interfaces defined, let's make a playbook to actually put it to work. All right, so here's our playbook. This is a little longer because this actually has 2 plays, whereas before we only had 1. So I've got play 1, configure router interfaces, and then down here I have play 2. I just wanted to show an example of a playbook with multiple plays. But notice how I've got them kind of locked down. The hosts here, I'm targeting the routers group. So that's the inventory group. So it knows it only needs to be applied to the routers. And in our connection, we're going to use a command line and then our tasks. So the first task, I just have task 1, set the subinterface VLAN. Here's the module we're using. It's the iOS config module. So let's go back to here and find it so we can see what it requires. And to use it, here it says to use in a playbook, you specify Cisco iOS config. That's where this comes from, just to be clear. And it requires an item called lines if we scroll down here. And lines is a list. So we need to give it, a list. If you think in Python terms, a Python list is, has the brackets, and then it can have multiple items. So what we're doing here is we're going to loop. So this is getting a little more advanced, our playbooks. They're going to loop through the interfaces. So let me, to make this more clear, let me save this, because what we had just a second ago, where let's look at router 1. This might be helpful to take a screenshot of this so we can have it and see how it works. So I'm going to have this at our disposal here. Now let's go back and look at this playbook. Okay, so the first task, set subinterfaces. We know what module we're using. It takes lines, which is a list. Here we only have one item, so we have one command that we're going to put. But this task has a conditional, means it'll only be ran if a certain condition is true, and that's denoted by this when. So when item.vlan is defined, then this will run. But what is item? Well, item comes from the loop that we're going to do. So here we're going to loop through, and you can see what this is doing. Interfaces. Well, what's this refer to? There's our Jinja template and syntax, meaning it's referring to this right here, interfaces. So if it's looping through our interfaces, look at how this is defined. It's a list of dictionaries. So if it's looping through, if you think of Python, for item in interfaces, that's what this is doing. And that's what item is. Item is the current iteration of the loop. So if I do for item in interfaces, the first time item is going to be this first dictionary. And then it's going to be, item is going to be this one. The third time through the loop, it's going to be this one. So here's the logic. When item.vlan is defined, so does this first one have a VLAN? No, so this is false, so it's going to go to the next iteration. When item.vlan is defined, now it's true, now it's going to run. So what's it going to do? Well, the first thing it's going to do, parents means it needs to do this before it does the line. So parents means it needs to type interface and then item.name. Whoops. And where are we at in the loop? We're right here. We're on the second iteration. So item.name is gigabit Ethernet 1.10. So it's going to type in interface gigabit 1.10. Then it's going to go to the line. Encapsulation.1q. There's our Jinja item.vlan. We're still on this iteration. There's VLAN 10. So this is how that works. When that's done, we're going to go to the third iteration of the loop, which is this last one. And when item.vlan is defined, that is false. So it is not going to execute. So then we're done with that task 1. So that's the logic of how that works. So I'm going to keep that open. So set subinterface VLAN, this is only going to really trigger twice, and it's going to be, if we look at our diagram, it's going to be this interface on router 1 and then the downstream interface on router 2. Now for set IP, you can see there's a different module here. And layer 3 interfaces. Here we have there's a config element, and then there's name and IPv4. They're on the same level. So there's our IPv4, and then there's our address. You can kind of see what it's doing, but how did I know to put all that? I got it from here. You might have to just look at this and try to figure it out. But it's kind of intuitive. And name. There's name. It's required. So let's look at the logic for this one when we're setting an IP. So when we get down to task 2, it also has a loop. It's going to loop through the interfaces. First iteration called item is going to be this one. And so when item.ip is defined, this is false. So we're going to move it to the next one. Is item.ip defined? It is defined, and it's 10.0.0/1 or 10.0.0.1/24. What's it going to do? Does this have a parent? This doesn't have a parent. So it's just going to, there's our name. Name.item is, that's the interface. And then there's IPv4 address, item.ip. So in this case, it's a little more abstraction on how it's going to be configured, because up here in task 1, the iOS config, I have to give it the commands, whereas task 2, I don't have to give it the commands, because I'm just using a different module here. And this iOS layer 3 interfaces, it has it built in where I can just do a little bit more of an intent-based approach here. So task 3, we're going to set the interface state. This one's pretty straightforward. It's using even a different module. So iOS interfaces, this one's pretty simple. Config enabled true just means, we're going to do a no shut. We're going to make sure the interfaces is up. There's a conditional here with 2 items. So item.state is defined. So let's think about if it's going through the loop, or if there's no loop here, excuse me. But it's going to look for the condition. So is item.state defined? It is here. And is it enabled? So if those are both true, then we're going to make sure that the port is no shut. And then that will finish our first play, which should get all the router interfaces. And then it's going to move on to the switch interfaces. So let's do what we did here and grab a switch interface. All right, so for our second play, we have configure switch interfaces, and then this is what makes sure that we're only hitting the switches. Once we get into our tasks, we have set access port in VLAN. So there's a loop and a conditional. So again, we're looping through interfaces. So the first time we go through the loop, it's going to have access to this first dictionary right here. When item.mode is defined, so do we have a mode? There it is, it's defined, and it's access. So, okay, so this is false. So this right here is not going to run. So it is not going to set this gig 108. It's not going to set that as an access port, which is what we want, because that is pointing up to router 3. We don't want that to be an access port. So we could keep going. Let's see, here's the second interface. So now item would be the second loop. Is item defined and is it access? Or item.mode, there's mode, there's access. So it's going to run on this dictionary here. So, and then name, item.name is going to be gig 101. Again, you can see, you don't see the commands themselves, but you can tell what it's going to do. Right there, item.vlan, it's going to pick up VLAN 10, and it's going to put that port in VLAN 10. I think that describes task 1 pretty good. Task 2, we're using the layer 2 interfaces module. Again, it's pretty intent-based looking. There's 2 conditions when the mode is defined and a trunk. So here, mode is defined and it's a trunk. And then we have our config item.name. So it's going to take gig 108. And then here's the allowed VLANs, item.allowed VLANs. So that's a list. So that's why earlier I said if we know what module we want to use, we can kind of structure the way we type this out in our hostvars to fit this real easily. So if let's look at this iOS layer 2 interfaces. So iOS layer 2, and I knew I had I knew what I wanted to do as far as allowed VLANs. So I just looked at this and I noticed, okay, this takes a list, if I can get it. So this takes a list. So I'm thinking to myself, when I write and when I describe this in the host variables, I'll make this a list. That way it's easy to pass into this. And again, this on the right is it's basically everything compiled. Let me exit this and let's look at our host of ours for switch 1. This is what we actually typed out. Allowed items, and then there's our list of VLANs that we want. So last is going to be very similar. I think this is exactly the same as maybe the first one, where we make sure the ports are no shut. So back to the iOS interface modules. So notice these modules change. It just depends on what you want to do. Config is true, but this only takes place when the state is defined and its state is enabled. So both of these, it's going to make sure that is no shut on. So this is the playbook that's doing 2 plays, and there's several tasks within each play. Hopefully it's pretty intuitive on what it's doing. Let's try to run this. Let's look at our inventory here. So we added the hostvars folder today, and we made a file representing each device's interface. And then we made a playbook to consume those. So let's see what this does if we run this. And just to make sure that I'm not doing anything sneaky, let's pull up the routers real quick and make sure there's nothing configured. All right, so here's just a show IP interface brief on the routers on the console. I hung up 2 on accident. It'll catch up. We'll come back to it, but you can see the only thing we have as far as IPs is still what we did initially on the ZTP, which is just the management interface. So we'll come back to this after we run this playbook. All right, it is done, and it did not take long. Let's scroll up because there's a bit of more output than we've seen before. So you can see the plays and the tasks. It makes it fairly clear. The first thing that might be concerning is the skipping, but this is not necessarily a bad thing. Remember in our playbook, we had that conditional with when. So when something is true. So if that turns out to be false, then it just skips it. So that's not bad. That's actually what we want. It's a good thing in our case. So it's going to skip anything that doesn't meet the condition, and then anything kind of this brown color, it did make a change on that. And then here it's given us to ensure item potency, make sure when you put commands in, they are just like they'd be in the show run. We talked about item potency last time. Here's more changes. When it set an IP, it made 1, 2, 3, 1, 2, 3 on the routers for sure. And then set access port on the VLAN should have been triggered for the switches. Set trunk ports again for the switches. And then we made some changes. Now, let's see. Now this should be idempotent, so let's make sure if we were to run this again, it should not make changes because they should already be made, and it should be smart enough not to try to push everything twice. So we can see here the output. Everything is okay, which is green, which is good, or it's skipping it, which is also good in our case. And you can kind of see how fast it's going. So everything does look good. Skipped, fine, okay. That looks good. Now let's go back to the routers. I'm going to just come here. You can see when it connects to the devices here. I'm going to go back to show IP interface brief and kind of cycle through router 1, router 2, 3, switch 1. I guess we can't really tell anything on switch 1. We will have to show run interface gig 101 down to the PC, and then 108, which is up to the router. So that one looks good. Switch to 101, 108, and these are obvious that they made a change. So let's test these PCs. The PC should be able to ping its new address that we gave to router 1. Let's go to router 1 real quick. And there's our 10.0.0.1. So let's open up PC1 and let's see if it can ping the the gateway. So if I look at its IP, it's 10.0.0.10. So if can we ping 10.0.0.1? And we can, so that's good. Let's verify PC2. So show IP, this should be 20.0.0.10. So ping 20.0.0.1. Okay, so we do have connectivity, but everywhere we should. So I can just randomly go to router 2 and let's see if we can ping. Make sure 2 can ping 10, 255, 12, 1. And then it should be able 23.3. Okay, so that looks good. Now we don't have full reachability yet because these are not running any routing protocol. So I think that about wraps this up. I think in our next video, actually what we may do is we may break this code up into what's called roles. It makes it a little more scalable. Network is so far in good shape, but we want to make sure we can scale it out if we need to.